Hey everybody, thanks for coming to our session. So I'm Felix Schneer from JP Morgan. I'm one of the tech leads on JP Morgan's Quorum project. And Quorum is an open source project from JP Morgan. I'm here with Cale.
Cale Teeter. I work on the blockchain engineering team at Microsoft and have been for since blockchain was a thing at Microsoft, so almost 4 years now, and working really closely with a lot of partners, and Quorum being one of the biggest.
Thanks. So today we have, it's a brief session, so it's only 1 hour, so we're going to split it in about half. I'm going to go over what Quorum and Quorum capabilities are, and Cale will talk a little bit about our partnership with Azure and what you can do on the managed blockchain service, and hopefully we'll also see a demo from Cale on how you develop with VS Code and Quorum. So, introduction to Quorum. So first of all, the first thing to know about Quorum is that it's a fork of Ethereum. So Quorum client is essentially, when JP Morgan looked at it a little while ago, which roughly 4 years ago, we compared some of the blockchain technologies and things that were coming out. And we made a bet on Ethereum. So we really like Ethereum. We like lots of things about it. We like the size of the community and how powerful it's been for the last 4 years. We like the idea of building distributed apps and the whole idea of Web3. And so Quorum is really a fork, and a close fork at that, of Ethereum. And in particular, Quorum client is a fork of Go Ethereum implementation, which is the most popular client on Ethereum mainnet and all of the other nets as well. So it's a very close fork, as I said. That means we keep up to date with all of the upstream changes. So as Go Ethereum gets new releases, we pull them into Quorum client as well. There's a big difference in Quorum and Ethereum is that Ethereum is designed for public use on mainnet, and the Quorum is designed for building private blockchains or consortium blockchains. And towards that end, we added the things that are needed in private world and not so interesting in public world, which is privacy, throughput, speed, and some of the other stuff. So these challenges were the things that our team looked at and added on top of Ethereum platform. So the key features are described over here, but again, the people operating blockchains in the private world or consortium world will look for things that are relevant to them, which is privacy or ability to send private transactions, security, decentralization, and a bunch of other things. And again, this kind of outlines the reasons JP Morgan backed Quorum project and backed Ethereum. So we really like the community, and Quorum really benefits from upstream changes and upstream developments into Ethereum directly. Some of the key features outlined here. So these are four pillars of what makes Quorum Quorum versus public Ethereum. So first of all, we added a privacy layer. Privacy layer is split into two different parts. We support zero knowledge layer. So our original POC was done with a Zcash company, but we have a few other implementations for zero knowledge layer as well at this point. Additionally, we have a private ability to send private transactions and communicate over smart contracts that are private. That's privacy features in Quorum. We also have a difference in performance and finality. They're kind of related because they're driven by the consensus algorithm. So Quorum supports a few different consensus algorithms that you can select when you operate a Quorum blockchain. And difference between proof of work is that we ripped out proof of work and we plugged in a very fast network optimized consensus mechanism based on Raft consensus. And you can have a very quick block creation time with upwards or downwards of 50 milliseconds per block. And you can also achieve a very high throughput through in Quorum as well. Additionally, we have finality. So essentially, because we're not using probabilistic chain linking, we're basically, when we tell you that a transaction will be in a particular block, there is no way that it's not going to be in a different block, and this is called finality. So there is no chain forking when you're using Quorum consensus algorithms, and there is no transaction reversal as well. Finally, the last pillar of what makes Quorum is permissioning. So again, Ethereum clients and Ethereum in public domain is specifically designed to be open, so anybody could be a miner or could connect to the public blockchain. In Quorum, while we like this feature, it's also desirable to have permission configuration where we would know every other node on the network in the blockchain. And so what we do is we give you several ways to configure this. And broadly, this feature is called permissioning. So you can set up a blockchain of only known participants. And it's built into the protocol. So here we see the high-level design of Quorum applications or Quorum blockchains. So on top, you would have the same traditional distributed apps, and they would operate and feel just like a regular Ethereum application because Quorum itself is Ethereum. So the development language is Solidity. It still has an Ethereum virtual machine and all the things that you're familiar with already on Ethereum. Under the hood, you would have a Quorum node, and every Quorum node has a counterpart called Private Transaction Manager. So Private Transaction Manager is a specialized piece of software that we provide with Quorum that basically executes and transfers your private transactions. And it's a specialized piece of software, but it comes with every installation of Ethereum, of Quorum, and that's what creates a Quorum blockchain. Finally, and the biggest part of Quorum is the fact that it is so compatible with Ethereum that all of the tools that you know and worked with on Ethereum in the Ethereum world will work the same way and will be automatically compatible with Quorum blockchains. So if you work with Truffle, if you use MetaMask or Ledger as your wallets, and if you ever looked at the OpenZeppelin smart contract library, all those things are automatically inherited and would run on Quorum as well. So you can pick any of these things and connect it to your local blockchain, as well as Remix. And essentially, any Ethereum tool is already compatible with Quorum. So a little bit more detail on the consensus algorithms that Quorum has. As I said, you have a choice when you configure a Quorum blockchain. There's three consensus algorithms that you can pick from, and we're likely to develop some more. One of them is specifically designed for network and block time creation. This is a Raft algorithm, and it's built on the etcd Raft implementation, and it's a very, very powerful and very stable implementation of Raft. So this is what we use for Quorum. Raft consensus algorithm. Over here, you have some pros and cons of it, and some of the more descriptions of it. The biggest issue with Raft is that it's not a Byzantine fault-tolerant protocol, but it is optimized for speed. The other algorithms that we ship with is a variant of proof of authority called Istanbul, and it is a BFT-tolerant algorithm. Again, the big difference is that Raft is a little bit faster in block creation time. Istanbul is a little bit slower, but in return, it gives you tolerance to n number of nodes. So you can configure your blockchain to tolerate however many failures you feel like you need in your configuration. Those are the two algorithms that we have. We also have Click implementation, which ships with Go Ethereum by default, and the difference there between Istanbul and Click is that Click does not provide finality. So it's possible that you can fork your blockchain. Some more in-depth implementation of how privacy is done in Quorum. So again, we work of the same idea of decentralization. It's delivered through a private transaction manager, and we ship a few with Quorum, so you can select which one you want. The production one we have is called Tessera, and this is a little bit of how it works. So on the client side or Go Ethereum side, what we now have is instead of just having public state, we now have public and private state. At some point in the past, we contracted the original developers of Go Ethereum, Jeff Wilkes and his team, to do this implementation for us. So basically, at this point, we support a private state and a public state along in the same client. The ways that it would be done, or the ways that you would invoke privacy features in Quorum, is that you would do your regular Web3 or whatever language you've been using for connected to your JSON RPC endpoint of your Quorum node, and the only thing you would add is private for. This is a hint to the client that this is a private transaction, and it should be distributed through the private transaction manager. So what happens is then this is a little description of how a private transaction is distributed through the network. But essentially what happens in detail is that a transaction is originated from a node. That node checks if it's private. If it is private, it goes to your matching transaction, privacy transaction node, which is a Tessera node. That will actually transfer the payload between itself and any of the parties that are supposed to be party to this particular transaction. Once the payload is transferred, a hash of this is returned to the client, and this is what gets written onto the public blockchain. Once it's written on the public blockchain, it's packaged into a block. The block is distributed as a regular block on the blockchain. And then there are two other events that may happen. So a participant node, when it receives this block and unpacks the private transaction, will talk to its counter Tessera node. And because it was a party to the transaction, it would receive the private payload and be able to update its private state. A node that's not party to the transaction would also talk to its Tessera node, but the Tessera node would return null that it does not have the payload for a particular transaction. And then it's a no-op for the Quorum node, and it would just skip this particular transaction. And that's in essence exactly how privacy is implemented on Quorum. So we also use for the encryptions, we use Argent2 library, and these are the curves that are being used on Quorum with Tessera or Constellation. So we have our public roadmap is on our wiki and on our website. We have quite a few things that we want to accomplish this year. And this is a list of some of these things that we want to take a crack at. And so we have a pretty big team inside JP Morgan that's dedicated to improving Quorum and improving Quorum features. And this team is growing, and this is a type of things that we're looking for, or looking to expand. Okay, so that was a little introduction to Quorum. But the common question is, what is it good for? So what are the use cases? So what can I build with Quorum? So essentially, the use of private blockchains is really up to people trying to set something up. But whenever you happen to meet the conditions on top with conditions at the bottom, you're looking at a good or potentially good use case for private blockchain. And I don't want to go to the details, but I will go into the details of examples where it was used. But these are the conditions that you need to meet. And if you do meet them, as I said, you're probably looking at a good use case for a blockchain. So based on the conditions, here are some examples of how it's being used outside right now, outside of JP Morgan, although I do have a few examples from JP Morgan as well. So some of these projects we're involved in, but most of these projects actually not our projects. So there's the first two projects are experimentations by various central banks. Project Haka is done by South Africa Central Bank, and Project Ubin is a multi-phase project that's being done by Singapore Money Authority, which is an equivalent of central bank for Singapore. Both of these are done in public, so if you just Google this information or click on these links, you will find much more information. Both of these projects used Quorum in various ways to accomplish different things. So Microsoft and EY have built quite a few projects on Quorum. The ones that I'm highlighting here is a royalty platform. It's a really cool idea where you can have, when you can trade your, let's say, for an example would be Xbox points to something like airline miles. And this is also done over Quorum blockchain. There's a few companies looking into Quorum in healthcare space. So Synaptic Healthcare Alliance is this very big alliance that's trying to look at how blockchain could be used to exchange patient data. And it's also the first experiment of POCs that they were doing, that they announced was done on Quorum. And finally, JP Morgan has a few of its own projects. Again, This presentation will be available afterwards, but if you Google any of these things, you will find lots of information as well. Okay, so now I'm switching to playing with Quorum. So, Quorum sounds interesting. So how do I get started? There's actually quite a few ways. So the easy way is our official Quorum Examples repo. It's basically a pre-configured repository for engineers to get started with quickly. It provides a few various configurations that you can use out of the box, either Docker or Vagrant. And it comes with several examples that showcase the power of Quorum. So a 7-node cluster is really an example of how to configure a 7-node, how to properly configure a 7-node cluster of Quorum nodes. And then there is another one called 5-node RTGS, which stands for Real-Time Gross Settlement System. And I believe this was also done by Brazilian Central Bank as an example of how to build a real-time gross settlement system on Quorum. So this project was actually developed by Central Bank and is open source at this point as well. The more advanced way is use some of our tools that we offer, which kind of allow you to get rolling with your cloud or with your cloud providers, with your hybrid cloud, or whatever other infrastructure you may have. These are a few examples of how you would do this. So we have Cakeshot, which is our own SDK and environment for engineers to kind of get developed with. It's bundled with an IDE, which is not too dissimilar from Remix, but it's more optimized for Quorum. We also have a Quorum Maker and Quorum Cloud projects. These two projects you can use to deploy to, as I said, to either your hybrid cloud internally or AWS externally. And finally, the most interesting things that we actually have right now is a new service that we announced with Microsoft recently, and actually Kale will talk about it a little bit more. So I'm just going to switch the presentations to his.
Cool. So I'll talk through some slides here, and then we'll set up a little demo, and I'll show you kind of what we got here. But working with JP Morgan and the Quorum team, over the years that we've been building applications with enterprise, we noticed a lot of the same kind of patterns that people were going through, or pain points. And the result of that is what you see in our platform today, because we have a lot of kind of devoted engineers looking at those pain points and trying to solve them. So one of the first things, if you looked at Azure before, and it still exists today, is there's a lot of templates up there to automate the infrastructure, right? So if you want to stand up a single, as Felix mentioned, a 7-node demo or the real-time gross settlement, you can do this directly inside Azure. We already have an offering and everything for that. We also have like multi-node. So if you said, well, I don't want to just have it on one single VM, I want to have it on multiple machines, and I want to manage those machines, that exists as well. And then the last phase was something we just announced last week, which was called these Azure Blockchain Service. We've been working on for a while, which is a managed service that basically, you can think of it more like a PaaS service. So essentially, we'll spin up the nodes for Quorum. In this case, Quorum's the first one on this platform. And basically allow you to have access to the RPC endpoints. You can manage them from a high level. The health of those nodes will be maintained by us. And it's for businesses who want to offload some of that to the cloud. We can handle that for you. The goal there is not to put every node in Azure. Obviously, Microsoft would love that because we like Azure. But in the real world with blockchains, it's not just about one central location, right? We want to have everywhere. So hybrid is key to our story. So having every financial institution we work with is not going to put everything in the cloud and walk away. They're going to put some in the cloud, and they want to put some on-prem. Probably have some in a different cloud provider, so we have to have connectivity for these. And this is key to our story with that today. So that's in preview. We just launched that this week. I'll show you what it looks like. We also, a while back, worked on this thing called Workbench you see on the screen here. And what that was about was we saw a lot of users building on top of Quorum and blockchains and saying, this takes like a month and a half, 2 months to do a POC. It can be quite costly, depending on the consulting firm you have in there and if you have Microsoft in there. And so we were saying, well, could we make that a little bit easier and cheaper for people to do that? Because we want adoption here, not to charge people tons of money. And so what we did was took some of the good stuff that people were building and said, let's just shrink that down into a framework So essentially what it ends up being is you write your smart contracts, follow the whole life cycle of that, test them, make sure that they're all working, and then bring them to this platform that we call Workbench, and essentially it'll create the app for you. Now, you can imagine it's not going to be production level quality. I'm just going to hit that button, okay, we're live, let's go. It's more of a POC framework. So we can interpret what's happening in your smart contract. We'll build a UI around that. We connect an identity system to it. So in this case, Azure AD. We connect our Azure Key Vault for HSM, for key management. And so all those things kind of just get connected for you out of the box. You could take these to like C-level executives, these kind of things. This is what we were targeting. And it's not like a terminal screen when you're going to these executives saying, hey, we got this thing working. They're like, I'm not sure what that is, but it's like a console screen. Like I need to see a UI. So that's what that was really about. And we continue to stand behind it. We're not abandoning it in any way. We just released Azure Blockchain Service, and a lot of times people are saying, well, why do you have two things? What is this other thing? So when you hear Workbench, think about POCs. Workbench can connect to Azure Blockchain Service. So there's a ledger underneath it. And originally, we just spun up a private Ethereum nodes and Quorum. And now we basically just have Azure Blockchain, so you can use that as well. VS Code was the last piece, and that was really just something really new. We launched it last week. So if you're using VS Code, if you look in the extension store, just search for blockchain, you'll see us there. And the idea there is to break down the barrier of like people actually starting to build their smart contracts. And so we want to be able to connect, allow people to do the create new project, get things running, get them deployed as fast as possible. I also have a place in my heart for this because I don't want to hinder somebody who's also an advanced user, right? So we want to make sure the basic users understand like what's happening here and how to get things done fast, but we don't want to get in the way of advanced users. And so I'll show you kind of how we built that to make sure that we don't kind of get in the way of people. And so again, I'll show you these dashboards live. We don't have to go through all these slides here. But essentially, in this dashboard that I'll show you here live in a minute, you'll see the basic telemetry. Now, it's not like a block explorer. You can actually attach any block explorer to these. The Web3 Labs guys have a really nice block explorer for Quorum. We've attached that to this, no problems. But we also surface basic telemetry up in the portal here at Azure. And you can also set alerts and all kinds of things on that based on transaction volumes, blocks, things like that. So you get some basic telemetry out of the box about what's going on up there to be able to handle that kind of stuff. There's a big story, and I won't get in, it's probably too long to get into today, but there's a big story around governance, right? So when I stand up a consortium with this Azure Blockchain Service, initially I'm going to say, hey, I'm standing up the consortium. I'm going to add so many nodes to this as me, and I'm member one. I'm going to add Felix to it, so I'm going to invite him. And when Felix is invited, he's going to receive an email, and he's able to then basically come in here as well. Now, obviously, we'd like him to be using Azure, but if he's not using Azure, he can obviously be using some other cloud provider or on-prem or something like that. Obviously, we can make the automated experience with Azure much cleaner. The other stuff we cover with documentation so people understand how to connect. But basically, the idea is I'm going to invite other people to my blockchain and to my consortium. And then we use a smart contract to basically validate who's allowed to be in the network. So just having network connectivity isn't enough. You also have to be validated in the network. A lot of the core stuff that the team has been building at Quorum, we're leveraging for that to do that kind of governance. It's a big story. This governance piece is going to be much bigger. So again, real quickly, and then I'll show you this live, is the slide. So basically, you can see we have the editor up here. So we were doing build, deploy, test, and integrate. This is kind of our model to make these things happen. So we write code, we get it deployed as quickly as possible. We can run our tests and everything up there. So we have integrated testing with Azure DevOps. We're also working, something we haven't released yet, but we're working on and we'll probably release here shortly, is automated tests for your Solidity smart contracts. So part of Microsoft Research has been working on inspecting a Solidity smart contract and being able to generate unit tests automatically for you. So you can get some test coverage out of the box there. And then also the integration side. So if you saw Mark's session yesterday, he's very passionate, and it's a great idea around connecting serverless components inside Azure. So for instance, once I create my smart contract, I get it deployed out there, then I have to write an application. So Workbench handles the POC, but when you're in production, what else do you need to do? You need to maybe just do some transactions or just read some data from the blockchain. We don't need to build a huge application in order to do that. And if anybody here has done that, there's quite a bit of code involved in using Web3.js and some of these other things to connect there. So what we did is try to make that simpler. So we have a thing called Logic Apps. which basically allows you to say, hey, just give me a key that I'm going to use to sign this, give me an RPC endpoint, and then give me your transaction data that I need for this. And then the serverless component will only start up, do that transaction, and then kill itself, basically. So this allows very scalable ways for you to build applications. And then you can connect other things to these. These are like a if this, then that kind of model. Very low code, just a little bit of code in there to kind of connect these things. But you could connect them, let's say the output of an event from a smart contract could go into a database for further analysis for something. So you can hook those up very easily with almost minimal code. So business developers, we think, could really benefit from this. And this is kind of an eye chart, but I always put it up here. So this is like, from a Microsoft lens, like what we're looking at for these kind of things. We see in the middle there, you can see the blockchain service, which also could be IaaS if you choose to run it and you want to manage the nodes yourself. But you can see all the surrounding mechanisms. It's kind of really important for me in working in this space for a while that we're able to influence Azure, which is this massive cloud machine, to basically change them so that they're more amenable to the blockchain. So we're always open to feedback. But for instance, when we first started down this path, key management is a big thing. And so we have an HSM in Azure called Azure Key Vault, but it only worked with RSA. So we said, okay, went to the Azure Key Vault team and said, we need to have elliptic curve. This is the curves we need. It's there today, right? So because of that, we're able to kind of push and influence some areas of Microsoft to change so that they're more amenable to blockchain. I think that's super powerful, and I'm kind of proud of that. So this is just kind of, it's nothing to memorize, but it's really just like a lot of our services and how we see them overlaid in a blockchain infrastructure. And with that, I need to set up my demo here. Just bear with us 1 second. Is that white connector here? Where did he put it? There was a white connector here.
Yes. And then I thought you took it.
Oh, he's got it. Thank you.
If you want, I'll take off mine.
Yeah, you want to take it off? Go ahead. There you go. Let me just get this on first. Go ahead. Yeah. Okay, so we can't have a demo without showing some code. So I want to walk through a little bit of the portal here just to show you what that stuff looks like. And then we'll basically get into a little code here and show you a project and how Visual Studio Code plugs in there and complements Quorum and the managed service. So what you're looking at here on the screen is the management portal in Azure. When you come in here, essentially you can create a new resource. And when you create a resource, you can basically just name it. You can just say Azure Blockchain, and you'll see our stuff here. So there's a blockchain category, but if you search for blockchain service, you'll see that. Additionally, if you search for Quorum, you'll see other offerings out there. As we mentioned before, the IaaS components, so you see that stuff up there as well. But let's look at one that's already deployed. So essentially what this is a consortium. You can invite other people, so here's the invite mechanism. You would click through there to do that. We have links out to our development kit, which are basically a lot of samples. Some of these are written by Microsoft, some are written by the community. So for those who don't know, there was an event before this called Ethereal, and we engaged with Gitcoin and put like 20 bounties out there, 19 bounties out there to build samples around this, and had the community actually build them. So it was super cool to see that most people could do it without our help. That was awesome because that's what I was looking for. But also we got some really quality samples out there. So if you're looking to get started with different scenarios, whether it be supply chain, financial driven, those kind of things, we have a lot of that stuff out there in our dev kit, is what we call it. The interesting thing here, there's different pricing tiers and you can go through that stuff, but the meat from the technical side is these transaction nodes that get spun up here. And this shows some of the integration, the tight integration we've done with Quorum, which basically says, hey, we have these different transaction nodes. You'll see the DNS names, which are essentially the RPC endpoints. You also see these public keys here. For those who are familiar, and Felix went through this with Quorum, there's also the Ethereum accounts that exist over there, but there's also this private transaction manager, and so there's a set of keys that go along with that. So if I want to do a private transaction with Felix, I need to know what his public key is. And that's what this public key is. It's being reflected in the portal here. So we basically integrated a lot of the underlying architecture of the private transaction node in here so that you can see that. When you drill through these, you can actually see that you can attach. We've again customized this UI for blockchain. Basically, you can come in here, get your access keys, reset them. So you have 2 access keys, so you can have one in flight and you can change them. You can attach your WebSocket or HTTPS, all the normal stuff that you would expect for an Ethereum or a Quorum-based blockchain. And with that, let's jump over to Sigma code here. So I have one set up just in case we hit internet bumps here. We tend to do that sometimes at conferences, so I just want to make sure we don't hit any kind of blockers. But this is Visual Studio Code. For those who don't know, we support pretty much every language under the sun is in here. Java, Python, C#, JavaScript, whatever your flavor is, you can come in here, even Solidity. So we worked a lot with our partners to take some things that they were using and expose them up through here through the Visual Studio Code interface. The big ones are, right now is Truffle. We worked with Juan Blanco, with the Solidity guys. We're working with a couple other spokes at Consensus and a few others to start onboarding more of them in here to make this easier for people to develop. But what you'll see down here in the corner is this Azure Blockchain thing, which basically, if you notice, I have 2 nodes here, and I just showed you that thing that was up in the portal there. This is reflecting exactly what's up in Azure. For those who can look a little closer, you can see that I'm logged into Azure down here. In the corner, you can see my Azure ID. So essentially, when someone spins this up, it'll prompt you for your Azure creds, and then it'll ask you, hey, which blockchains do you want to put in here to kind of play around with and use? Think of this like connection strings. So we're trying to make this a little bit more like a database so that people can understand like how to connect to it. So instead of having to go through a myriad of configuration files, we essentially walk you through and I'll show you what it looks like. If you say, hey, I want to connect to another consortium in Azure, it'll basically say, what's your subscription in Azure? Again, I'm logged in, so that's where it's getting that info from. And then essentially it'll enumerate what we call resource groups, which are basically containers and things up inside Azure that allows you to contain some of your resources. And looks like it's taking a little while to connect there, but that's okay. That's why we have one already pre-baked. Let me just open an empty folder here and we'll do a deployment. And all I'm doing there is just opening up an empty folder. So we're going to start a new project here. And then in that project, basically what we're going to do is scaffold out a new blockchain. And so you see when you hit F1, you get all kind of different, in Windows, there's this thing called a command palette. You can see all the different things. You can see stuff prefaced with Azure Blockchain. If I type Azure Blockchain, I'll see all the different features that are up there. It'll basically filter them, and you can see I can do some of the same things, like building smart contracts, deploying contracts. Ganache is integrated here for local development. So if you're on a plane and you don't have network connectivity, you can still get some stuff done. If I say create new project, you'll see I get basically I can go get a truffle box, or I can use a basic project, which is a template that we put in there that just gives you some of the basics. This is in preview, so you're seeing some of the debug output here of like what's happening underneath the covers. But essentially what it's doing right now is going and unboxing a truffle box that we built that allows basically the hello world or the basic project scaffolding for you to basically get started here. So you can see it's setting up the box, downloading all the bits that it needs for that. In a second here, you'll see it complete, and then we can go through the rest of it. But from an end user's perspective, someone who's not familiar with blockchain, if someone gave them a Solidity smart contract and said, here's the contract, can you go test this or use it? Really what we want to get to with this is, yeah, I can go use it because I don't need to know how to configure Truffle and do all these different things with it in order to take advantage of it. Looks like we are having a little bit of internet slowdown, but that's why we got to back up over here. So that's cool. So basically, once that thing would complete, we'll pop back over in a second and make sure we can essentially, we've customized the menus here. So basically, when you have a Solidity smart contract, you can do things like build and deploy. Now, when you do a build, obviously, it's just going to do a local compilation. But the deploy thing's kind of interesting because what we did here was key management, and when people are getting started with blockchain, can be a huge barrier because everything has to be signed if you're writing things to a blockchain. And as part of that, we want to make sure that we can lower that barrier as much as possible for end users. If you're an advanced user and you know everything about the configuration of how to set these things up, you still have your Truffle config over here that you can go to town with and customize to your heart's content. But for those who don't know, we actually have a Ganache instance already built in. So if I do a deployment here, it'll essentially fire up Ganache, sign my contract, put it on the blockchain, do everything automatically for me. You can notice also that it picked up this CT Consort, which is also the name of my consortium down here. So that's where this like little connection string thing comes in. So now if they click on that, we'll do the same thing for a chain that exists outside, right? So this lives in the cloud. And we'll basically update the truffle configuration. So if you look at what the output of this actually does, for those who are familiar with truffle, you'll see there's a development section there. That's the local development. It also creates this on the fly for you, this CT Consort one. And you can see it sets everything appropriately for me. The provider that we use for the HD wallet, essentially it's going and getting a mnemonic. So when I spin these up, and actually I'll show you what that looks like. Let's see if our other one's done, by the way. Looks like it's still going, sorry about that. But when you do a deployment here, and if I pick this guy, so this would be one that exists in Azure. Hopefully our internet's working. I don't know, it seems to be a little weird here. What I should see here eventually is a little drop down at the top where it generates a mnemonic, and that will basically complete that configuration for me. So it'll generate that config on the fly for me. And it looks like it's not popping up. So you can see it's deploying down here, but I think my internet might be hosed or something here. I'm not sure what's going on. Not a problem though. So we follow the same stuff as far as like private transactions that Felix mentioned. So in the private transaction context, you can see here when I'm deploying these, I'm actually setting a private for. We can do all the exact same stuff. So again, if you're an advanced user, you can come in here and kind of customize and say, what do I want to do with my contracts? If you're a new user and don't know too much about what's going on there, yeah, you can see my network connectivity was down there. If you're a new user and don't know what's happening out there on the blockchain with all this private for stuff, it'll just work, right? So it'll create a public transaction for you. You can see everything function. And then whenever you want to step up and start doing the private fors, you can do that as well. So we're here to kind of support a lot of those different mechanisms. The last thing that we put in here in our current release is a lot of this code generation stuff you see down at the bottom here. So I mentioned those logic apps, which are basically like these really bite-sized serverless functions that you can use. And what we did here is said, okay, so if you have your smart contract, you have it deployed, you tested it, everything works, you probably want to do something with it. And one of the things is these logic apps. And so if you see generate microservices for smart contract, what we're going to do there is take the output of your compilation. We know what address it's got deployed to. We know the ABI for it automatically. We don't need to ask you for all that stuff, which most tooling would do. And then basically we can essentially go build what the logic app is in Azure. So in the initial release we have here, we'll build that out. And we basically have an output file that you can take over to the Azure portal and say, here's my logic app. You obviously put your keys in over there that you want to use for production. Other than that, it's turnkey. We don't have to go build that thing ourselves. It's basically building a script for us to take into the portal and say, use this. Next phases we want to go with this are to automate that even a little bit more, have that push directly into Azure. But the initial phase here, we were just trying to get out. We ended up kind of pushing that back a little bit so that we could have some debug features in here. The other piece that we're adding that's not exists right now, but will be coming in the next couple weeks, is interactive debugging. So we have the Truffle debugger plugged in here, so you can do the whole F5 thing and you step through just like you do in any IDE for Solidity. We think that's going to be improved developer productivity. But the idea here is really to empower developers, make them, if you don't know anything about blockchain, we want to make sure that you're educated enough to know, hey, how do we do deployment and build? Because I know how to do that with an IDE, but I don't know how to do it if I have to go download a myriad of tools. The other thing you'll notice is so Microsoft's adding some stuff here for Azure, obviously, but the other stuff we're trying to get out of the way with. So from the Truffle standpoint or from the Solidity standpoint, we want to work with those. We've been working with the Ethereum Foundation for some time. So some of the features you see in Remix are also being injected into here so that we can make this a world-class kind of IDE for developers. Again, we don't claim to know everything about all these things in blockchain, but we're trying to use the best of breed and bring that together. And if there's I don't know who's in the room, but if there's other people who are interested in, and you have a company that does something in blockchain, whether it be smart contract analysis, we've been engaged with a few ISVs on that front. We're plugging them in to do right-click analyze smart contract, for instance. Enterprises are super big on this kind of stuff. Just building it, deploying it, and having a DevOps pipeline is one thing, but being able to analyze it and give some sort of score about what your smart contract looks like from a security standpoint is another thing. And so we want to kind of break that wall down as well. So again, if there's anyone in the room or anyone interested also in helping us here, we would love to talk to you to plug in more people to this. And that's pretty much it. I hope you guys got a sense for what we're doing. We have a booth up there. Love to talk to you guys, and we're big Ethereum and Quorum supporters, so we're happy to be here and help out.
Yeah, so just like Kale said, we have 2 booths actually up there. We have a Quorum booth separately, and we have Microsoft booth. We also have tons of swag. If you have any questions and you want to learn more about either one, just feel free to come stop by and talk to us. So this is it.
I think we have plenty of time for questions, yep. So if anyone has any questions, yeah.
Sorry. I don't know whether you can show that, you talked about the workbench where you create the UIs, the starting UIs. Is it part of this toolchain?
So it's not part of the VS Code toolchain. So the way we see that is when you start working with Workbench, obviously you're going to need a smart contract. So someone's going to have to build a smart contract. That's not part of Workbench. So if we're using this tool and you're onboarded through this to basically go deploy, either using Ganache or something locally, build your smart contract, test it, make sure it's cool. Once you're done with that, basically you go fire up an instance of Workbench and give the Solidity file to it. That's the flow we see right now. We're open to ideas. I mean, we could, the sky's the limit there. We could essentially hook up your smart contract, right-click, deploy to Workbench. If people think that's a good thing, we're happy to put it in there because we can just make an API call and push that over for you instead of you having to do it manually. I'm really kind of focused on keeping developers who are in the IDE, like not business developers, but kind of core developers, in the IDE. I don't like to be jacked around and have to go to a browser to do this thing and this kind of thing. I try to keep people in this as much, so we'd love feedback, if you guys think that's important.
Would you be able to share with us a little bit of the challenges related to user experience with your stablecoin?
We don't have a stablecoin, but you guys.
I'm assuming you're talking about JPM coin. So I'm sure there's going to be tons once it gets into once we start implementing, but it's not at that stage right now. So I can't really comment on that. In terms of just basic UI challenges that we have with blockchain, so like when blockchain gets adapted in bigger corporations, they don't really care about the part where you can have decentralized identity. So ledgers, nanos, MetaMasks is not so interesting in the context of a corporation, because each corporation will have its own Active Directory or LDAP or something that will provide the identity services. Quorum kind of addresses it anyways because you can map your Ethereum accounts through a node. But in terms of UI, this is kind of defeats the entire purpose of decentralized identity. So there's definitely lots of challenges. This is just a tiny example.
One question here.
This is a technical question. On Quorum, when you create a smart contract that is going to live inside the private area, so you have to decide which parties are able to interact with that smart contract at deploy time. Is it possible to later add or remove a party from access to that?
It's a good question. So if you were to look at it right now, at the version 2.2.3 of Quorum and Tessera 09, the short answer is no. You create once, and that's going to be your provenance forever. You can use any subset of the original creation. So let's say you create a smart contract with 10 parties. You can then execute a private transaction between 5 of these parties or any combination of. However, you can't add the new parties that was not part of the smart contract. So that's the state of things as it is right now. We're working, so this was on my roadmap. This is a big thing that we need to address, and a fix is coming. Basically, you will be able to extend the provenance of a contract to another party or remove provenance of the party that already had access to it. So that's coming. I don't really have dates for you yet, but it's being worked on.
One more question.
Well, thank you for the presentation on VS Code. Comparing remix is night and day, right? So I do have a question for the VS Code. Actually, 3 questions. One is, does it support other type of network other than Ethereum? Second thing is, for Ethereum, does it provide ability to decompile existing bytecodes? And also, does it have any support for analyzing the Ethereum traces where you help to do some kind of production troubleshooting?
Great questions. So one thing I didn't show when I was doing it here, and I reset my network connection, so it looks like things are working now, so that's good. When you compile this in here, as far as the decompile, we don't have anything that's like reverse engineers, like takes bytecode and makes Solidity out of it. I mean, there's libraries out there to do that. If you think that would be useful, that's interesting. We do have basically stuff like this, where once you do have a build, and these are your output files that you get from Truffle. So a lot of the stuff's automated, so for the deployment stuff, but if you need the ABI for some reason or the bytecode, you can come in here and right click and just get those. So you don't have to kind of fumble around for those in there. As far as like other languages, what we have right now, so if you notice when I said connect to a consortium, you can see local Ganache, the Azure Blockchain Service, and then we have testnet and public Ethereum. So we'll work with Infura, we'll work with local geth nodes, so for testnet and mainnet. So this is not something that's just for enterprise. Like, we actually see this being useful for public developers as well. And for sure, other chains that come along, it's interesting. I think we could definitely hook into it because the models would be different for a create new project for something like, let's say, Hyperledger even, than something like Ethereum based. But definitely it's something we want to do. Microsoft's not. I mean, we have a strong interest in Ethereum and in these things, but we also, support Corda and Quorum and all the other different flavors out there. So yeah, if people want to work with us to build other connectors for other blockchains, we'd be happy to do that. And did I miss your other question? You said you had 3. Sorry. Yeah, so the other thing we have that we haven't shown here yet that we're working on is once you deploy it, the last piece we're working on is not exactly that, but basically taking that smart contract and creating a visual representation of it. So it allows developers who are not familiar with writing code to talk to them to say, okay, I got my smart contract, I tested it. Can you give me a UI so I can interact with it, like fill in values and see what happens? So we're working on that right now. So that should be coming, but that's as far as we went with the traces. Yeah. Sure.
Yeah. Hi. How do you deal with oracles, or is that even a thing in the private permissioned blockchain world?
I'll let Felix speak, and then I can speak on it too. Yeah.
I mean, so Oracle concept obviously works on Quorum as well. So if you were to use something like Chainlink or any other implementations, it would out of the box work on Quorum as well. The idea first, before you get to Oracle, is once you set up your use case on your blockchains, then you have to figure out, okay, what external data do you need? And that's when you figure out how to connect that data into Quorum. But again, Quorum is Ethereum, and there's a ton of implementations of oracles or Oracle-like data feeds into Ethereum. So you can use any of them. They'll work out of the box for Quorum.
And just to comment on that, so we also this week announced some other product we've been working on for some time called the Confidential Consortium Framework. So back at DevCon last year for Ethereum, I think in November, we open sourced a thing called the EEVM, which was an enclave-based EVM. And so we've extended that now with a Confidential Consortium Framework, which basically ties directly with Quorum, by the way. We've done a lot of work directly with Quorum on this. So you can think of Quorum saying, hey, I can do a public transaction. Everybody can see the transaction. I can do a private one, like Felix said. And I can also do a CCF one. And this is basically an enclave that's sitting there that has some code on that we can run. Very similar to like Oracle, where we need off-chain compute that we can use, that we all agree upon. We have some attestations around, this kind of thing. So this is another alternative to things like oracles.
Hi, you mentioned a 50 millisecond block time up to, I'm guessing that's with the optimized Raft consensus. I'm wondering if you could speak to, what sort of times you get if you do the Istanbul BFT or if you even add the ZK layer in there. Does that slow it down?
Right, so Raft is optimized for block creation, and actually it's also only creates blocks when you have pending transactions on the network. So otherwise, if you're at block 100 and there are no transactions, Raft with Quorum will remain on block 100 until there are new transactions. With Istanbul, it's a little bit different, but you have the power to configure it operationally when you start your blockchain. You basically say, I want my block time to be 1 second, 2 seconds, whatever you feel is appropriate for your use case, and we do provide some advice on how you should configure it, especially once we know your performance metrics or how heavy smart contracts is or how much transactions your chain is expected to process. But this is a configurable setting for operators of blockchain, so it's either 1 second and up to whatever you want to configure. And the idea is that every second there's going to be at least one round of Istanbul voting, and that should result in a block created. So that's also along with however many transactions get processed by your EVM at that time. In terms of, again, performance is a little weird because on Ethereum you have to know how much lifting your smart contract is doing and how much data is being passed per transaction before you can actually exactly answer the question in terms of what performance is going to be. But we have, this isn't rocket science. We have some calculators for you to figure out how it should be. There's some public work that has been done to test Quorum to figure out what are different metrics for it. So just if you want to stop by afterwards, and we'll tell you where to get the stuff. So.
Sure.
For the serverless functions, when a smart contract executes, is data from the contract passed to the serverless function, or does the serverless function have to somehow read that data back?
So it works both ways. So essentially, the Ethereum logic app connectors that we have up there right now, which work with Quorum, private transactions, the whole thing, they're just a block. So you can feed input from, let's say, a file system, database, Twitter even. Like you could have something that triggers off the internet and causes a transaction to get created and signed and that kind of thing. So the data can flow in from other connectors. Could be static, but it's probably not much use. Mostly it's usually dynamic. And then on the outside, the other thing, because a transaction has to be created and then we retrieve the response, we do have reads in there too, so we can basically stall the logic app and say, hey, go do the transaction, wait for the result, and then when you get the result, do this thing. You could also trigger on events which are closer to real time. So as an event occurs, we could pick that up and do something else with it. But you can think about these logic apps, they can be like a little puzzle. You can put them anywhere you want in the chain, basically.
Quick question.
Yep.
Are the cloud functions already in, or that was something that's being worked on?
We had a whole round of them last year. We did in November, which were the basic Ethereum reads and writes. We've extended those with the private, we can do private transactions and all those things up there now. So they're continuing to evolve. But yeah, everything's out there right now for anything you want to do basic for Quorum. I mean, basic reads, writes, reactive events, those kind of pieces.
What are you doing are you only using gas for the halting problem? So are you just setting a limit on how much gas a contract can run, and other than that, you don't use gas, or are you configuring gas at all here?
So in Quorum, you have some flexibility to actually configure this versus default Genesis for public Ethereum. So we have variable contract sizes. You can actually set it. We have variable transaction limit sizes, which you can set as well once you prime your chain. And our block limit is much, much higher. It's something like 4 billion by default. As a minimum being itself, I think about 800 million gas. That said, Quorum only uses gas for like making sure that you don't lock your code doesn't lock. That's it. But you can also operate Quorum with either gasless mode, which is a default right now, or with gas, more like a regular Ethereum. And so you'll have to have some accounts that have Ether on it, and use them as a faucet to give other Ethereum accounts ability to transact on your blockchain. So this is configurable, so you can use this, but by default it's gasless. So gas is not being used.
Totally gasless for everything?
Gasless for everything. And I mean, gas is being used, when you do transaction, you have to say, okay, here's how much gas I'm providing, but you don't have to have this on your account. And it's only used for ensuring that your contract doesn't spends it, and that's it.
We do the same, by the way, in the managed service. If you notice my truffle configurations, how the gas costs were set. So we follow the same model there. We also, I just wanted, real quick, I just stood up a logic app, and those are the connectors for the actions. So deploy a smart contract, execute a function on the smart contract, write, get some stuff back from it, and also query. And there's gas settings with those too, so you can customize it. Just for the gentleman who was asking what we have up there now. You can go do this right now. I got one I can talk about. I mean, there's a bunch, but I pick on one because I like it because Xbox. So inside Microsoft, we have basically publishers, EA, Activision, Ubisoft, these kind of things that are publishing, AAA games, and they get royalties based on people using them, right? So if someone buys that disc and puts it in their system, there's a money that goes to that publisher, right, from Microsoft. And so basically these royalties, it was a very complicated scenario to kind of handle them because you can imagine there's millions of gamers, this is going on constantly. Reconciling that requires an outside auditing firm and all kinds of things because there's a lot of money involved there. And so we worked with the guys and built this on Quorum, which basically allows the privacy of saying an Activision can do its transactions with Microsoft along with an auditor who's in that stream as well. So 3 people in there. I'm simplifying it. But they can all see the transaction details and be able to prove them. Someone like a competitor to them, like Ubisoft, who's also participating in here, cannot see those, but he sees his information. And this is the way we utilize it for that process.
And there's a ton more. The latest one that I thought was kind of cool is that Louis Vuitton Corporation built a thing to validate whether their luxury items are actually authentic. And it's a project with IoT and a bunch of other things, but it is running on Quorum blockchain. And there's a ton more. I would suggest stop by our booth. We'll give you some more examples as well. So.
If there's anything else, just come up. We're going to go ahead and shut down here. But thanks.
Thanks, everybody.